Hey guys, this is 10.3. It's going to be on composite figures. And basically what composite figures is a combination of 10.1 where we are taking the areas of those shapes we learned and we're going to combine them into one weird looking shape. So let's start with some definitions here. Composite figure is a figure that can be separated into regions that are basic plane figures. And a basic plane figure is like a triangle, parallelogram, trapezoid, rectangle, circles. All those that we just learned in 10.1. So what we do to find the area of a composite figure is we divide, not division, but we just split up or divide the regions to find each area. And then we add all those areas together, or we find the sum of the areas. So, for example of that, number 1, here we go. We have a rectangle and a trapezoid. So this is going to be our area 1. This is going to be our area 2. So we find the area of the rectangle, and then we find the area of the trapezoid, and we add those together. That's the idea. That will give us the whole area of this composite figure. So the rectangle, it's just base times height, and we have that pretty easily. That's just going to be the 12 times 23. So the area of the rectangle is quite easy. That's just 276 centimeters squared. Now we need to find the area of the trapezoid. So area of the trapezoid, we need 3 different things. We need each base. So we got this one. This one is 23 centimeters. And we have the other one, 15. If you can see, this 23 is the same as this 23 since they're opposite sides of the rectangle. So area of a trapezoid is area of the height times the bases averaged together and we need to find the height now. So that's it. All we need to do is find the height. So we need to find the height where it is perpendicular from one base to the other. And how do we find that? Well, we know this is 12, and we know the whole thing here is 18. So what does this have to be? If the whole thing is 18, this is 12, this must be 6 centimeters. So the height is going to be 6. Okay, and then when we do that, we get 114 centimeters squared. And so we're looking for the area of the composite. That's going to be 276 plus 114, which is going to give us 390. Cool, not too bad. All right, so let's do number 2. Let's do several of these. Yeah, let's do a lot of them. I'm going to go a little bit faster now. So again, if you have any questions during class, I'd be happy to help you. So we have 3 shapes here. We have a parallelogram here. We have half a circle. And we have half a circle. Okay, so you can see that each of these half circles share the side of the parallelogram, and that's their diameter. Okay, so the radius of this circle, so let's first get everything ready. So the area of half a circle, that's half a circle, this is number 1, is going to equal our regular area, pi r squared, where our radius is 6, times half, because we're taking half of that circle. Our second one is a parallelogram. And our third one is another half a circle. which is also going to be 1/2 pi the radius squared. And since they share the same side, this also must be 6. Okay, so let's first get our area of the half circle. That's going to give us, let's see here, 113. Oh, so that's going to give us 66.05 inches squared. No, sorry, not 66. 56. Yeah, 56.05, which means this is also 56.05, which we could just combine those really and just did the area of the circle. So let's do that. So we don't need 3 actually. We could just combine that. Instead of doing 1/2, we can just do the area of the circle since they are the same. So that ends up with 113.1 inches squared. And now we got to define the parallelogram. So a parallelogram is just base times height. So let's erase all this. We know this part is 6, which means this other radius must be 6. So we know it's going to be 12 inches for the base or height, doesn't matter, they're exchangeable. And then, commutable I mean, and then the height is going to be 5, or base, doesn't matter. So that's going to give us 60 inches squared. And so our composite shape is going to be 113.1 plus 60. And we get 173.1 inches squared. Booyah. All right. Number 2 is done. Number 3. We are trying to find 3 shapes again. First, looks like we have a rectangle. Second, triangle. And third, half a circle. So we'll call this 1, 2, 3. So 1 will be area of circle. I'll just put C for circle. We have to find the radius. That's pretty easy actually. Since this will be the same as this, and that's halfway, we know our radius is going to be 9 feet. 9 feet. So it's going to be pi 9 squared. Number 2, a little bit trickier. So let me erase this. 2 will be the triangle. All right. Let's see here. So it tells us this little section right here is 7. Okay. We also know that this whole thing is 26. Good to know. So if that's 26, we're gonna have to do a little creativity here. So we know that this is 9, right? The radius is 9, which means this is 9 as well. This is 9 feet. So if this is 9 feet, what is this gonna be if the whole thing is 26? That's gonna be 17 feet. Okay. So if that's 17 feet, let's erase some of this a little bit. This is 17 feet because we know this is the radius of 9 feet because we knew this was 9 feet and that was the radius. So if this is 17 feet, this is 7 of the 17 feet. That must mean this is 10 feet. So the height of the triangle is 10 feet, and we know the base is 9 because it's the radius, 9 feet. So the area of the triangle is going to be 1/2 base times height. Okay. Third one. Third one's the rectangle. Okay, we already got this. This is 17 feet. And the base is 9, so that's easy. Area of a rectangle is 9 times 17. So here we go. Let's put these together. So that is going to be approximately 127.23. This is going to be 45. This is going to be 153. So our composite is when we add those together. 127.23 plus 45 plus 153. And don't forget your units. These are all in feet squared because they're area. So our answer is going to be 325 approximately 0.23 feet squared. Cool. All right. Number 4, a little trickier. We have two shapes. We have our semicircle and we have our triangle. So let's do our semicircle first, triangle second. So our circle is going to be half a circle. So we're going to take half of the area, pi, and the diameter is 16. So that must mean the radius is 8. So that's going to give us 100.53 approximately feet squared. So there's the semicircle. Now we need to add that to whatever the triangle is. So for triangle, we need the base, we got it, 16, times the height. Ew, boy. Don't know the height. So we could use trig if we wanted to. We have an isosceles triangle. We could do something where we break this down because we know this will be 60 and we know this would be 30. Because why? Oh no, it wouldn't be 60. So we don't know that actually. Nope, sorry, take that back. What we could do is law of cosines to find the angle and then go and do trig. That's one way. There's an easier way though. Since this is an isosceles triangle, that means if we go from the vertex perpendicular, these will be the same. So that means those will be 8, those will be 8, and we have a right triangle. We can just do the Pythagorean theorem. So 8 squared plus something squared, the height, is going to give us 17 squared. Ding, ding, ding. So after, let's just go through this fast. And after we get x squared equals 225, x equals 15 or negative 15. 15 is the only one that makes sense. And then we plug it back in. Triangle, area of a triangle is base, 16 meters, times height. We just found it, 15 meters. Going back here, whoops, not feet, meters squared. So the area of our triangle is going to be 120. So the area of our composite is going to be 100.53 meters squared plus 120 meters squared for a approximate answer of 220.53 meters squared. There we go. Okay, number 5. Let's do it. We have a lot to break down here. Okay. So, what we could do is break these into 2 separate triangles, but since they gave us the height and we could figure out the base, we don't need to do that. We could use this as one shape, 2 shapes, 3 shapes. So let's do area of the triangle first. Area of the triangle. Do we have the base yet? No. But it does tell us the height. So the height is 9.6. We need to find this. So we are going to have to go do the square right away. How do I know it's a square? because this side's going to be equal to this side, and this side's going to be equal to that side because they're perpendicular to each other. We would learn that in a later section, later unit, sorry. So if this whole thing is 25.4, so I'm going to have to erase some stuff. If this whole thing is 25.4, how do we find just this? Good question. Well, we'll have to think about this. Let's see. Since this is an isosceles triangle over here, we know that this side is also going to be 12 meters. That doesn't really help us, but it does, because it tells us that this is 9.56, we don't know what this is, and we have 12. So we can use the Pythagorean theorem to find this side right here. And if we find that side, it's going to be the same as that side. So x squared plus 9.6 squared is going to equal 12 squared. And when we do that, we end up getting x equals 7.2. So this is going to be 7.2, and this is going to be 7.2. And since they're both 7.2, we know this is going to be 14.4. And that helps us, because that tells us the base of our triangle. So that is 14.4. Now we need to find the area of our square. So we already have one side, so we can find the rest. It's just 14.4 squared. And then we have to find our trapezoid. So our trapezoid, we have one base. We already know that's 14.4. Oh, and we have 10. Cool. Now we just need to find the height here. The whole thing is 15.4, and this part right here is 14.4, and the whole thing is 25.4. What does this have to be? Has to be 11. Okay, so the area of our trapezoid is going to be, let's change color, it's not easy to see. It's going to be 11 times the average of the bases which is going to give us, let's see, 134.2. Area of the square is going to give us 207.36. Area of the triangle, 69.12. Oops, not 112, 0.12. So the area of the composite is when we add all those together. 69.12. These are all in meters squared. Oops, 134.2 meters squared, and that gives us 410.68 meters squared. Cool. All right. So that is composite figures. Now we're going to be still using composite figures, but we're going to be doing something we did a long time ago. So let's see if you guys remember. We are going to find the area of shaded region. So the way you do that is you find the area of the whole thing. Find the area of the whole thing. And then you subtract the area of the non-shaded region. So if we subtracted that, if we took it out, what would be left? The only thing that would be left would be this region, right? All would be left is the purple. So that's the idea. You take the area of the whole thing. So you take the area of the entire figure, and then you subtract the area of the non-shaded regions. That's the idea. Okay, so I'm just going to do the evens, or let's do the odds here. So the odds, we take the area of the whole thing. So the area of the rectangle is going to give us 14 times 25. It's 350. The area of the non-shaded region, which is just a triangle here, is going to give us 1/2 times the base. The base here is 25. because it's going to be the same as this side, 25, times the height, it tells us, 11. So the area of the triangle is going to be 137.5. And to find the area of the shaded region, we take the area of the whole thing and we get rid of the non-shaded region. So that all that's left would be the shaded region. That's the idea. So we get area of shaded region is going to be 350 minus 137.5. And our answer is going to be in centimeters squared, since we're working with area. There we go. Okay, number 9, a little bit trickier, so let's do it. We actually have a trapezoid we could be working with here, but it's not, yeah, we could do a trapezoid, or we could break it into a rectangle and a triangle. Both work. We could do either one. I'm going to do the trapezoid. So the area of the trapezoid, or I'll say entire region. Entire region. The area of the entire region is just the area of the trapezoid. So it's going to be the height. What is the height? How do we find that? Good question. I think we're going to have to break this up a little bit. So, in order to find the height, we're going to have to find this height right here. And since this whole thing is 37, and then we know that this is 17, that must mean this is 20. So this is going to be a Pythagorean theorem. So 20 squared plus x squared equals 25 squared. And then when we solve that, we get 15? 15. Okay, so x is going to be 15. Nice. So 15, which means this is going to be 15. Which means our height of our trapezoid is 15, and we already know our bases. It's going to be 15. Oh, sorry. The base of our trapezoid are here and here, because this is our trapezoid. So the bases are parallel. So remember, a trapezoid is a quadrilateral with one pair of parallel sides. So those are obviously the parallel sides. So we get 17 plus 37 all over 2. So remember that we're doing the area of the entire region. So that is going to give us 405. And then we have to subtract the area of the non-shaded region. The non-shaded region is just the circle. So we found out the diameter. We found out the diameter is 15, which means the radius is going to be 7.5. So the area of the entire circle would be pi r squared. Since we're taking half of a circle, we have to multiply it by 1/2. And that's going to give us 88.36. So the area of the shaded region, which is what we're looking for, is 405 minus 88.36, which is going to give us 316.64 inches squared. And we're done. All right, guys, if you have any questions,